Okay, welcome back. Now we're going to talk about covalent bonding and really molecules and see how that differs from ionic compounds that we just finished studying. And as you'll notice from the image here, once you know something about covalent bonds, then you really know a lot about biomolecules and can answer a lot of questions about the human body. So it's kind of an important topic for those going into the medical field. So real quick, as kind of just to put it all in one place, I want to take a look at the three models of chemical bonding. And so we'll start with ionic bonding, which we already studied, but notice that we have a metal coming together with a non-metal, sodium in this case, coming together with chlorine. There's actually a transfer of electrons to form ions. So then we have positively charged sodium, negatively charged chloride, and they come together to form a compound. And ionic compounds on the solid state structure on the molecular level or the atomic level form what are called lattices. So that's what this is, kind of the solid state structure of an ionic compound, repeating units of positive, negative, positive, negative, positive, negative, and so forth. So that's ionic compounds, just in a nutshell, kind of a review. And then now we're going to introduce covalent bonding and covalent molecule or covalent compounds, which are also molecules. So here we have chlorine and bromine, two nonmetals coming together to form this bond we see in the middle that we're symbolizing with a line. As you'll come to understand, this line is actually representing two electrons. So anytime you have a line between two atoms, you actually have two electrons, which are sometimes also shown as two dots for two electrons. Okay, so that's a covalent bond, and basically it's considered to be a sharing of electrons. So these atoms here, chlorine and bromine, are sharing electrons in order to achieve that very stable state, which is an octet. So we'll review the octet rule in just a moment, but kind of the same idea as the ionic compounds were actually transferring electrons to achieve the octet, but covalent compounds share electrons to achieve that octet. Okay, so then once we have on the solid state, what we have is individual molecules. So kind of different than the ionic compounds where the lattice was the solid state structure, and on covalent bonding and molecules, we have individual discrete molecules. And then lastly is metallic bonding, which I'm not going to say much about. But basically, when you just have a metal, you have what's called an electron sea, or a sea of delocalized electrons to form a bunch of bonds, metallic bonds. So that's kind of an interesting model that hopefully we'll come back to at another time. Okay, let's revisit the octet rule. So basically all noble gases except helium have this electron configuration that I'm not going to worry too much about. I didn't require that you understand this in too much detail, but basically what I would like you to notice is that the noble gases have what's called a full shell, which in this case is these 8 electrons. Okay, so 8 is kind of the magic number here, and that's why we have what's called the octet rule. So the octet rule states that atoms tend to gain, lose, or share electrons in order to achieve that 8 electrons, 8 valence electrons. So in the ionic bonding model, you notice that atoms were transferring electrons to achieve the 8 electrons. That is the similar configuration to the noble gases. But in this covalent bonding model, we'll look at how atoms can share electrons in order to achieve this octet. In these 8 electrons in the outer shell. But as always, there are many exceptions, so we'll look at a few of those. Okay, so again, just a real quick review. We've got sodium chloride. This is just another review of ionic compounds coming together to form an ionic compound. There was a transfer of an electron to chlorine to give ions, and then we get our compound. And now hydrogen chloride is going to be a combination of hydrogen atom with chlorine. And notice that hydrogen's not going to transfer its electron to chlorine, but rather they're going to share their electrons. So this is one way we could write that, is we can share these 2 electrons to form one bond between the two. So again, that gives hydrogen 2 electrons, which in that case is fine for hydrogen because hydrogen is one of the exceptions to the octet rule. And chlorine, if you count all of them, 1, 2, 3, 4, 5, 6. So let's just count 1, 2, 3, 4, 5, 6, 7, 8. If you count all of those, then chlorine has that 8 electrons, which is what we're going for. So they're sharing electrons in order to achieve that octet. Okay. So I'm going to move on from there. So drawing covalent molecules, we use what's called Lewis structures. And so now that you know that each covalent bond contains 2 electrons, I'm going to give you some rules that will help you understand how to draw these, how to predict the structure of a covalent compound or a molecule. So here are the rules. We'll take a look at those and then we'll do some examples. But basically, to draw a Lewis structure, which again, Lewis structure is a representation of covalent compounds. Of covalent compounds or molecules. Okay, so we sum the valence electrons from all the atoms. That's the first thing we're going to do, is add them up. You add 1 for each negative charge and subtract 1 for each positive charge. So if there is a charge, then you need to do some extra work there. Then you're going to draw the skeleton structure with atoms attached by single bonds. So this at first will be a little challenging. You won't always know how things are connected, and we don't ask that you know that right away. In fact, connectivity, or how the atoms are connected, will be given to you in some fashion. Then you're going to complete the octets of the atoms bound to the central atom. Okay, so you'll be connecting the atoms, and you're going to put electron pairs around the atoms, the outside atoms first, until they all have an octet. And then if you have any extra electrons from that total valence electrons you added up in number 1, you'll place those on the central atom if there's any left over. Okay. If the central atom doesn't have an octet, then you have to use multiple bonds. So we have something called double bonds. We have a single bond represented like this. We also can have a double bond where there's 2 electrons in each of those lines, and then we can also have a triple bond. But that is the extent of it. So that would be a total of 6 shared electrons between 2 atoms. So those are the possibilities when we talk about multiple bonds. Okay. So Lewis structures, let's just do one of these. I guess they're both coming up. So CCl4. Now the first thing, let's see if I'm going to put all these up and so that I can get the rules up here. So there's the rules. So let's look at CCl4. For the first rule is to sum the valence electrons. So you would actually need to go to your periodic table and recall how to determine the number of valence electrons. And remember, it's associated with the which family it's in, or which group it's in the periodic table. So chlorine, it turns out, has 4 valence electrons, and carbon, sorry, I'm not sure I said carbon, but carbon has 4 valence electrons, and chlorine has 7. So notice that we have 4 chlorine, so we need to multiply this times 4. So we end up with a total of what? We have 28 plus 4 is equal to a total, so we'll add these together, total of 32 electrons. Okay, so you're not going to go beyond that 32 electrons for this structure. That's the total valence electrons for this compound, for this molecule. Now we're going to draw a skeleton. So we're going to go to Rule 2. Draw a skeleton structure with atoms attached by single bonds. Okay, so we're just going to place the carbon in the middle, because it's often in the middle. You'll get used to that. Carbon is often a central atom. And I'm just going to place the chlorines kind of around it. Okay, now the next rule says complete the octets of atoms bound to the central atom. So those are the chlorines that are bound to the central atom. Okay, so carbon is the central atom. Okay, so we're going to place electrons. So each chlorine already has 2 from this bond here that's sharing with carbon, but I'm going to add 6 more to each chlorine so that it has a total of 8 for each chlorine. And you want to get good at counting up these electrons. Okay, so there's 8 electrons on each of the chlorines, and now we need to kind of count. So the last one says place extra electrons on the central atom. Let's see if we have any left over. So we have, if I count on each chlorine, so on this chlorine, this first one, we have 8 times 8 more. This is chlorine number 2, and this is number 3 and number 4. It looks like we have 8 on each, so we have 8 times 4, which gives us our 32 electrons. So notice that that matches our total. We are not going to put any more electrons on this structure. The last thing to do is to kind of make sure every atom in the structure has an octet. So clearly the chlorines do, we know that. But what about carbon? Notice that carbon has 4 shared bonds, and each of those contain 2 electrons. So carbon does have an octet. So the structure is complete. All right, let's try another one. So we'll do this guy here. COCl2. So we have 4 valence electrons for carbon. We're going to count up valence electrons first. We have 6 for oxygen, and so we'll add that, and then we have 2 times the 7 for chlorine. So what does that give us? We have 10 plus 14, so 24 electrons for this one. All right, so carbon again is central. It's written first. It's often central when it's present. So that one's pretty clear. And we're just going to go ahead and put the other atoms around this carbon. So Cl, Cl again, and then we have an oxygen. Okay, so there's our structure. We did number 2. We connected the atoms, and now let's complete the octets of the outside atoms. So I'm going to go ahead and put these all on the outside atoms first, and then I'll count them up to see how many I've used. So it looks like we've got 8, 16. I've used 24. Did I use 24? 8, 16, 24 electrons. Okay, there we go. So I've used all 24 electrons. Now we want to make sure that all the atoms have an octet. We know that the outside atoms have an octet, so let's just look at carbon in the middle here. Does carbon have an octet? What do you think? If I'm counting this shared pair of electrons here, so that's 2 plus 4 plus 6. So I think it only has 6 electrons. And so then what has to happen is carbon clearly does not have an octet. It only has 6 electrons. And so if we look down at our rules, if the central atom doesn't have an octet, try forming multiple bonds. So I'm going to take one of these pairs of electrons on oxygen and share it and make a multiple bond here. Okay, so there's a multiple bond. That means this is gone. I don't have an eraser at the moment, otherwise I would erase that. This is gone, and so now this oxygen here has 4 shared electrons and 4 non-shared electrons. But carbon now has 2, 4, 6, 8 electrons, so it has an octet. And we can say, all right, the structure is complete. And let's just redraw it again. I would draw it like this. And the Cl. Now you can kind of clearly see that all of the atoms in this structure have an octet, and the structure is complete. Okay, so my rule for you is to really focus in on these rules. My suggestion is that you focus in on these rules. The rules will really keep you straight. So as you try problems, as you do the practice problems, and you try to draw molecules, really think through and use the rules. I would just be careful with this number 2. It's going to be kind of, you will feel uncertain at times in terms of what to place as the central atom, but you'll get better and better as that as time goes on, and you'll figure that out as time goes on, and you'll also be told in this quarter what is the central atom. Okay. I think that's it for this video. I encourage you to look into, to try the practice problems and to really draw a lot of molecules and a lot of Lewis structures. It will get easier the more problems that you try. Take care.